Hello, students. Today we will study chapter number 4 from ninth standard of NCERT syllabus. I am Professor Thomre here. First point in this chapter is to study first point is we know this atom consists of fundamental particles as electron, proton and neutron. So we will study discovery of these particles. First, discovery of electron. So electron was discovered by J.J. Thomson in 1897. He carried out cathode ray experiment. So this experiment is called as a cathode ray experiment. So he observed the stream of negatively charged particles coming out at cathode towards anode. So this is the stream of negatively charged particles and that is coming towards anode. These particles named as electrons. Now what is this experiment actually? This is called as a discharge tube. So this is a glass tube containing this negatively charged electrode, cathode. This is positively charged electrode, that is anode. Air is placed at low pressure in this glass tube. This is the vacuum pump to control the pressure of gas in this discharge tube. Then it is connected to high voltage generator. When electricity is passed, then rays given out from this cathode, and these are negatively charged particles. They are attracted towards positively charged electrode, that is anode, and these particles called as a electrons. So this is cathode ray experiment for the discovery of electron. Next is discovery of proton. Second particle present in atom is proton. So proton was discovered by scientist Ernest Goldstein. So he observed the same gas in the discharge tube with a different situation, that anode emitted positively charged particle and these named as a canal rays. His experiment led to the discovery of proton. So similar type of tube, means this type of tube is used, and one more here partition that consists of hole, that is called as a canal. So the rays given out from anode, they are called as anode rays, or they are named as protons. So that is about the discovery of proton. Now discovery of neutron. Chadwick discovered neutron. So neutrons are present in the nucleus of all atoms. So we will revise this. Discovery of electron by J.J. Thomson. Discovery of proton, Goldstein, and discovery of neutron, that is Chadwick. Then we will study first model given for the atom, that is what is the structure of atom. So that is explained by different scientists. We will study all these models of atom explained by different scientists. So first model of atom that is discovered by this Thomson, called as a Thomson's atomic model. So he proposed that atom is uniform sphere of positive charge due to presence of protons, as well as negative charge due to presence of electrons. So this type of positively charged and negatively charged particle containing spherical cloud of positive charge. So that is given by Thomson. Atom as a whole is electrically neutral because negative and the positive charges are equal in magnitude in this sphere. Therefore, atom is electrically neutral. This model, Thomson's model, was also known as watermelon model or plum pudding model or apple and apple pie model. So these different names are given for this Thomson's model. Now the limitation. It failed to explain how protons and electrons were arranged in atom so close to each other. So this is the limitation of Thomson's model. Then next scientists tried to explain about the structure of atom was Rutherford. So this is called as a Rutherford's atomic model. This model is based on this alpha particle bombardment experiment. These alpha particles were bombarded on thin gold foil. So in this experiment, this is a source of alpha particle. Then these alpha particles are emitted. These are passed through or they are bombarded on this thin gold foil, and then the scattering of this alpha particle take place. They are scattered at different angles. So this is the detector of screen. Then observations of Rutherford's particle, alpha particle scattering experiment. Observations. First observation is most of the alpha particles pass through any hindrance, means most of the alpha particle they pass through this gold foil without any deviation. So that is the first observation. Second observation is some of the alpha particles deflected from the original path at the noticeable angle. So this is the deflected their original path by a noticeable angle, means measurable angle, maximum angle. Then a few alpha particles of they are bounced back at their original path, means one of the alpha particle that is given out back from this the original path. So these are the observations. On the basis of this experiment of alpha particle scattering and uh, these observations given by Rutherford are the most of the part in atom is empty. Most of the part in atom is empty. Second is there is a positively charged center. There is a positively charged center in atom. So it contains nearly whole mass of atom, and this center is called as a nucleus. So this type of center, for example, so this type of circular spherical positively charged center, and at the center there is a nucleus. This mass is embedded in this part, and other part is whole mass of atom. It is embedded in the center. The size of nucleus is very small as compared to atom. So this size is very small as compared to this size of atom. Then the electrons revolve around the nucleus. Electrons revolve around this nucleus. So that is the structure of atom given by Rutherford. Then drawbacks of Rutherford's model. According to Rutherford model, electron revolve around the positively charged nucleus, which is not around the nucleus, positively charged nucleus, which is not expected to be stable, but the charged particle in accelerated motion that gives the circular path. So this circular path, that is electron, these are the charged particles, they are revolving around the nucleus, that is given in the first statement. Then Rutherford model could not solve the problem of atomic mass of atom proposed by the existence of proton in the nucleus. Then other model given by Bohr's model. So this is the important model given by Niels Bohr in 1913, and this is the model best explains the structure of atom. So atom consists of heavy positively charged nucleus. The whole mass of atom is concentrated in the nucleus. So this is the statement given by Rutherford, and the same is repeated in this Bohr's theory. Electrons in an atom revolve around the nucleus in definite circular path, and these definite circular paths are called as orbits, or these are also called as energy levels. Each energy level is associated with the definite amount of energy. Each this orbit having the definite amount of energy. The change in energy take place when electron jump from one energy level to another energy level. So these are the statements given in the Bohr's atomic model. The maximum number of electrons that could be put in a particular shell or the energy level is given by Bohr and Bury. According to Bohr and Bury scheme, the maximum number of electrons that can be accommodated in energy level is given by 2n square, where n is 1, 2, 3, 4, or it is denoted by symbols K, L, M, N. These are the shell or orbit around the nucleus, and this is the formula for accommodation of electrons in that orbit. The maximum number of electrons in orbit will be 8 electrons, even if it has the capacity to accommodate more electrons. So that is called as an octet. Electrons are not accommodated in a given shell unless earlier shell are filled, that is the stepwise filling of shell is followed. So this is given by Bohr. Then orbit. So what is orbit? Orbit is a circular path. Orbit is a circular path. So orbit is a circular path. So this is the first orbit, like this. Second orbit. So this is the first orbit, second orbit, third orbit, and the nucleus. So the central part is a nucleus, and this is orbit number 1, orbit number 2, orbit number 3, like this. These are the orbit numbers. Orbit number 1 is denoted by symbol K, that is called as a K shell. Second orbit is denoted by L shell. Third orbit is denoted by M shell. Then fourth orbit is denoted by N shell. So K, L, M, N, that is 1, 2, 3, 4. These are the orbits, or they are also called as a shell. Then next point is the distribution of electrons in orbit or shell. The distribution of electron in orbit can be obtained by using formula 2n square, where n is the number of orbit. So number of electrons in first shell, that is the K shell, can be calculated as n is equal to 1 by substituting value in this formula 2n square. So 2 into 1 square, that is equal to 2. Therefore, maximum number of electrons in K shell, that is the first shell, are 2. The number of electrons in L shell, that is the second orbit, here n is equal to 2. Therefore, 2n square formula, we will substitute value of n as a 2. So 2 into 2 square, that is equal to 8. So the maximum number of electrons in L shell, that is the second orbit, will be 8. In similar way, maximum number of electrons in any shell can be calculated. Then valence electrons. So what is valence electron? The electrons present in outermost shell of atom, these are called as the valence electrons. These electrons determine the valency of atom. So valency is the combining capacity of atom. Their tendency to react and form molecules with atoms are the same or different elements. From the atoms having the valence electron less than or equal to 4, the valency is same that of number the valence electrons of that atom. For example, valency of magnesium. Magnesium atomic number is 12, electron distribution is 2, 8, 2. So number of electrons in the outer shell, these are the 2, and therefore valence is 2. The number of valence electron exceeds the 4, then valency equal to 8 minus the number of valence electrons. For example, valency of oxygen. Atomic number of oxygen is 8. So electron distribution is 2 and 6. So 6 electrons are present in the outer shell. These are more than 4, and therefore valency can be calculated as 8 minus 6, that is equal to 2, and 2 is the valency for oxygen. Valency of atom with 8 valence electrons is 0, as they have filled the valence shell and cannot gain or lose electrons to form the molecules of compound. The next point is atomic number. So what is atomic number? Atomic number means the number of protons present in the nucleus of atom. Number of protons present in the nucleus of atom is called as atomic number, denoted by symbol Z. The atom is electrically neutral, therefore protons and the electron numbers are equal, and therefore atomic number can be given as Z is equal to number of protons, and that is equal to number of electrons. So that is the definition of atomic number. Now mass number. Mass number is denoted by symbol A, and it is the total number of protons and neutrons present in the nucleus of atom, that is called as a mass number, denoted by symbol A. Protons and neutrons together are called nucleons. So number of electrons present in the nucleus of atom is represented by n. So that is about the mass number. These are the important concepts in atom. Then isotopes. So before definition, we will consider one example. Here it is a carbon element having atomic number 6 and mass number 12. This is again carbon element, atom of carbon element, atomic number is 6 and mass number 14. Here atomic numbers are same, but the mass numbers are different. These are called as isotopes. Similarly, one more example, hydrogen. This is hydrogen, one atom. This is hydrogen, second atom. Atomic number 1 and mass number here 1, mass number 2. So same atomic number, different mass numbers. These are called as isotopes. So atoms of the same element having same atomic number but different mass numbers are called isotopes. This is definition of isotopes. Applications of isotopes, where these isotopes are used. One of the use of uranium isotope, it is used as a fuel in nuclear reactor. Isotopes of cobalt, they are used in the treatment of cancer, and isotope of iodine is used in the treatment of goiter. So examples are carbon 612, 614, hydrogen 1112, chlorine 1735 and 1736. So these are the examples of isotopes. The last point given in this chapter is isobars. So what are isobars? Here we will consider examples. So first example is it is potassium. First example is it is a potassium having symbol K. Atomic number is 19. Atomic number 19 and mass number is 40. Next element is argon having symbol Ar. Atomic number of argon is 18 and mass number here is 40. So what we observe here, the atomic numbers are different and the mass numbers are same. So these are the atoms of different element having same mass number but different atomic numbers. These are called as isobars. So isobars are atoms of the different elements having same mass numbers are called isobars. Example given here is potassium and argon both have mass 40, and that is about the definition of isobars. And that is about this chapter, structure of atom. Thank you.